Alright. So, I'm going to talk to you a little. They asked us to tell you a little bit about how we use code in real life, right, in our jobs. So I'm gonna show you that, and I think you're gonna see it's probably not the kind of thing that you'd expect. So right here under my name, you can see I've got a few different titles. I'm the founder and director of BitSpace. We'll come back to that. I'm also the director of design communications. I'm a curricular director at a college the university called the Illinois Institute of Technology. And I work in the College of Architecture, which is designing buildings. Right? And I'm the founder of Sandbox, which is a multidisciplinary design firm, and you'll see some stuff from that too. So when I describe to people what I do for a living, this is how I describe it. I'm a multidisciplinary experience designer. Do you guys have any idea what all that mumbo jumbo means?
No.
So multi means many, right? And disciplinary, that's like discipline. Discipline is, sometimes you refer to a job that you might do as a discipline, like as an architect as a discipline. So I do multiple things, and they all have to do with designing experiences. So what that means is, that could be anything. That could be the experience of walking into a building. That could be the experience of using a mouse to click on a piece of software. It could be anything that you would consider to be an experience. I'm interested in designing that. I'm interested in changing the way people interact with the world. And people do that with real things like this cart, and people do that with software things like on the computer, right? I'm also an educator, so I've been a full-time teacher for the last 14 years. But at the same time, I also have a full-time job working. So I kind of always, glutton for punishment, I've always had two jobs. I'm a creative technologist. I like to use technology in creative ways. So in my architecture career, I don't design normal buildings. I don't design the kind of stuff probably like you live in. I design kind of wacky stuff like, well, we'll come back and see, but houses that try and look like they're floating. You can see a kitchen countertop here that glows in the dark, made out of glass, so when you turn the lights off, your kitchen glows. But I also like to make things with software. So I'm formally trained. I went to school to become an architect. I also went to school to become a software engineer to write software, so I have 2 degrees. But it all comes back for me to this. It's a kind of interesting story. Maybe some of you have heard of this before. When I was your age, well, probably a little bit younger, when I was about 8 or 9, I got my first computer. I got my first computer game, and this was the computer game. It was called Zork, and this is how you interacted with a computer game. So you are near a large dungeon which is reputed to contain vast quantities of treasure. It was all text. There were no pictures. Right? This is where the computer wasn't fast enough, we weren't sophisticated enough to be using the computer to draw pictures to make computer games, so they read like books, right? But the interesting thing was, even though this was a book and it was text, there was still a map, right? So when you're in a room, you have an options. You could say go right, or go left, or go east, or go west, right? That's how you interacted with it. You didn't use a joystick, you said go east, and you could go east. And you were going through a maze, right? You didn't know it because you're just reading things, but there really was a map, there really was a space. Now this was the kind of computer, this is what my computer looked like. The computer that I got when I was 8 in the 80s, in the 1980s. So this is what the screen looked like. And when we wrote programs, this is what writing a program, this is what code looked like. Now, these are from the back of a magazine. So the internet didn't exist when I was a kid. If you wanted to write a new program or you wanted to find out something new, you had to buy a magazine. So about Compute magazine and Byte magazine, and in the back, like the back 30 pages of these magazines were page after page of page like this. And if you wanted to have a new program on your computer, you would literally type this in line by line. And as you know, if you've written any code, if you make a little bit of a mistake, it doesn't work right? So when I was 8, this is how I spent my free time, was like copying down numbers like this so that I could play games. And they came out of magazines like this. I found this is from the 80s, I think. It's like April 1981, right? And look, the future of computers. So how many years ago is that? That's like 44 or 34 years ago, right? But so that's an Apple Watch. So that's how long it took, right? From the time that somebody's like, oh, well, this is how we're going to be computing in a couple of years. It actually took like 34 years for that to come to fruition. So at the same, has anybody ever seen these before in the library? Yeah? So these happened when I was a kid. Like they didn't exist until I was 8 or 9, and these came out, these books, Choose Your Own Adventure books, came out. These are at the same time that we're playing Zork. So if you think about like Zork, like there really isn't any difference between one of these choose your own adventure games and what interacting with a video game looked like at the time, right? So I started to think, oh well, maybe I could make my own. I started writing my own choose your own adventure books just because I thought it was fun. Maybe some of you have done the same thing, right? And then I realized, oh, maybe I could write the computer program so I could do the same thing. It seemed pretty easy. And if you look, like this was a simple computer program. 10, input your name, and then you have a variable, right? You guys know about variables and like algebra and programming. And so you would, oh, that's a smart board, I can't touch it. Forget about that. And then you would say print, and it would say hi, and it would print out whatever your name was.
Even if it doesn't touch it, the laser won't pick up your hand.
Will it pick up? Yeah, it's sensitive. So, and then it says, how are you? And it tells you your name, nice to meet you. So it was really simple, but this is what got me started in computer programming. This was literally the first thing, and after that point I thought it was the coolest thing ever, right? So I tried to figure out how could I make Zork. That was really the impetus. Okay, so now fast forward, that was when I was 8. A lot happens from the time you're 8 until the time you're 18, and over that time I realized that I wanted to design houses when I grew up. That's what I wanted to be. I wanted to be an architect. And I knew that in high school. So I got ready for that. And I went to college. And when I went to college, I graduated high school in 1994. So in the late 90s and the mid 90s, this is how we drew things in school, right? We drew with pens, we drew with pencils. This is all drawn by hand, right? So you can see top view and side view. But what happened when I was in college, this happened. Everything changed in media. So it used to be we drew by hand. Now, this is when Toy Story is 1996, 97? 95. Okay, so Toy Story, when I go to college, Toy Story comes out. As do a whole bunch of new computers with new things that they can do. And so I decided, wow, this is really awesome. This makes so much more sense. This is how everybody's going to do it in the future. And I thought, this drawing by hand thing, it's good, but this is what I really want to do. And so this was a couple years later, but this happens when I'm in architecture school. It totally changes the game. The entire field of architecture is completely different almost overnight as a result of the computer. Now, for a little bit of context, the internet is also happening for the first time, really, for mainstream people at the time. This is what the internet looked like when I first discovered the internet. So this was in 1994, 95, when we wanted to go to what you might think of as a web page now. You did it like this. Just like Zork, you didn't see pictures. You didn't have all kinds of buttons and cool things to click on. It looked like this, and this was awesome. This was the coolest thing in the world. And it might not seem like it now, but it certainly was. Now, the interesting thing happened in between my freshman year and my sophomore year of college. The internet had pictures all of a sudden. The World Wide Web happened. Right? So now, when we go to another computer somewhere across the world, now it looks like this. And this blows at the time, not now, this blows our minds. Like, I can't believe that we can actually do this. Now, in order to do it, you have to start to write code. So I was in college and I went and got a job at this bookstore, and I told them, yeah, I know how to code. I know how to make web pages. I do that all the time. I had never done that ever before in my life. So I got the job. You can say that's a good thing or a bad thing, and it was at a bookstore. So the good thing was I walked out of the job interview and I went straight to the bookshelf where the books on how to make web pages were. And I bought 2 of those books, and I went home and I read all those books, and I came back to work on Monday and I knew how to make web pages. So I didn't need a school, I didn't need a teacher. The internet didn't really exist, so I couldn't download things. I relied on books, but I taught myself how to make web pages. Now the cool thing about that was, this is actually a web page that I made in 1996. So again, it looks really kind of bad, but at the time, this was cutting edge. Like, this was the top, the best. Now, what that happened, so then there's a little black time again. So now we go from like 94, 95 to, I think this is 99, and the other one was 2000, this is 2000. I graduated from college, from architecture school, and I moved to New York City. New York City is where all the cool stuff was happening in architecture and technology, so I wanted to be there. So I moved, and I got a job, at this really cool place where I could do both architecture and web design. So we designed things like websites like these for big film festivals. One of my clients at the time was Robert De Niro, who you might not know, but is a very famous movie star and has a big movie company and a film festival. And so we were building websites for them, and among other people. But at the same time, I'm designing things like this. So part of my day is spent doing drawings and talking to contractors and making things get built, kind of wild places like this house, where you have a glass bridge that connects you from the parents' room to the kids' room on the other side, and a beam that floats in space, and all kinds of cool fiberglass and stuff all over the place. Not probably like the houses you live in, but maybe cool places to live still. Right, so there's our kitchen, living room. At the same time, we're interested, because we're doing websites and we're doing buildings, we're interested in how do we start to bring these two things closer together. And for me, what I realized, I met this artist, a famous artist, and he introduced me to some technology that allowed me to control light. So you see all these cables and things back here? At this point, I knew a little bit about code. I could code and make things interactive like these websites. But what I was interested in was making the physical world do things. Not have websites, pages on our screen, but to have lights turn on. I wanted to write computer programs that would turn on the lights automatically in the room. Or maybe they would do things like when you walked, they would follow the light. So what this project was, this was like the next big transition for me in my career, where I said, now I know how to code. Now I know how to control lights, so I can, as I move through the website, I can change colors on the screen, I can do some interesting things. And this was the same time that I moved, so this was right before I moved from New York to Chicago. So I moved to Chicago, I left this cool place that I was working for, and I started my own company, doing basically the same stuff, designing buildings, designing websites, making interactive media, and I had this fun crew of guys that I worked with, and I don't know. What's that?
Were you going with the mustache?
No, that's me right there.
Really?
Yeah, in the middle. And this is on the top of the New York Times building before it was finished. This was for a magazine photo shoot. They made us put us in all kinds of fancy clothes and a fashion shoot, and yeah, it was tons of fun. So at this this company's name was Sandbox, and these were the kinds of things that we did at Sandbox, right? So you can see here I'm talking about houses that look like they're teetering on the edge, bathrooms that have glass walls that you can see through, and stone that you can glow, all kinds of fun stuff. Houses, really expensive houses for really rich people is the bottom line. It was a lot of fun, but there was an aspect of it that the computer part wasn't there. So in addition to doing all these cool things for people, houses and stuff, we also started to do projects like this. And this is where some of these things about controlling lights and using code come back in. So we now have these walls. We did a project and we were able to basically cut these walls out of a house in Vermont, and we reinstalled them in this gallery so they would swing. But the cool thing is we hooked up sensors to them. And the sensors allowed us to see where these walls were at. So we knew when they rotated, we knew where they looked like. So if you look here, you can see that as the walls would rotate, a little computer model we programmed would also show us what those walls were doing. The cool thing is that they turned them into like joysticks. So now when I move the wall, I'm able to change what the lights do. Or when I move the wall, I change the projection that's on the back screen. So I'm interacting with the world. All of this happens through code. So I use programming to be able to read the sensors, and then I use programming to control what the lights do or to control what happens on the screen. So I'm interested in making things like this was a prototype that we had built, and you can see we build models, we build diagrams, and these are models with sensors and motors and little computers that control how this thing moves. So the idea is that maybe we turn our houses into robots, and parts of our houses are actually moving and responding, so that if you want your room to be bigger, maybe you touch a button and your room grows and gets bigger. Or you want your room to get smaller, so you touch a button and your room shrinks and gets smaller. These are the kinds of things that you can do when you connect writing code to the physical world. So here's a kind of example, and you can see some of this at BitSpace, a part of this at BitSpace. something that we built for a museum. So it's kind of like a jukebox. You pull out all of these different slides, and when you pull them out, the light turns on, and it allows you to watch these videos about these different people down on the end. So there's a screen, and there's a little place you put your hand in, and there's no buttons. You just move your hand back and forth, and it's able to navigate through the video. And so all of this is also programmed media. It's about the way that the physical world and the digital world come together. So we can do things like, now this gets into teaching, so this is the kind of stuff that I teach. These are some of the projects that my students work on. This is a game of Pong, where you bounce a thing back and forth. It's a kind of simple video game, but instead of using a controller, you use your body. So as he walks back and forth on the stairs, this thing slides back and forth with it. So it's like you're interacting with the video game with your body. Now mind you, this happened long before the Wii existed. So we're trying to do these things before, again, we make things like this. We make video games where people play in the video game, and depending on what happens in the video game, it affects what happens in the real world. So this is a plastic ceiling that we made, and as people walk up and down the stairs here, oops, that plastic ceiling moves up and down. And that plastic ceiling then is connected to the video game, and crazy things happen in the video game. So at a certain point I decided, you know what, I need to go back to school. I know this architecture thing, and I can write some code, and I can start to work with this a little bit, but I need more. I needed more school. I needed somebody who knows a lot more than me to help me figure some more things out. So I went back to school. I was 30-something when I went back to school, and I got a degree in software engineering. So now I'm not only an architect, but I'm also a computer programmer, fully legit, and I started to do some work in that discipline as well. So I've worked for large architecture firms developing software for them. So in this case, this is a 3D modeling program called 3D Studio Max, and we're building custom software that goes into this that allows this architecture firm to connect the world of data to the world of design. Now we'll see if this will work. So some of the stuff that this has to do with is about looking at cities, using the computer and code to create models of the city so you can imagine new futures. So this is a project done by some of my students at IIT. This is, do you have any idea what this is?
A bus driver? The bus route.
You're right. So this is about bus routes. Only what do you think about these bus routes? Any ideas? They're kind of wacky looking bus routes. They look like buses that you ride on? No? What's different about them?
They look like they're being randomly and procedurally generated.
They look like they're being randomly and procedurally generated. How you understand the word procedurally generated at 11 or 12 is awesome, but surprising. So that's entirely right. These are bus routes that are procedurally generated. So this research project is interested in what would happen if buses didn't operate on a set route, but if the route was different every time the bus moved. And instead of following a route, it knew who it was supposed to pick up. Right? So what we're doing is we're creating something like a video game. It's a simulation that says if a bunch of people all over here decide that they wanted to call for the bus, and we knew that where they needed to go, that maybe the bus, like a robot, could find its own way through the city. Right? Totally different way of thinking about public transportation that would be really hard to test in real life, right? But if we use computer programming, we can test those ideas without that. Okay? Now, the thing that's interesting to me about these projects, when I go to school, when I go to IIT and I'm talking with scientists and professors and all these people who are really smart and very serious, and I come in and I tell them that I'm going to do some really serious things, but I'm going to do it with video games, they laugh at me. You have a question?
Would those buses be kind of like impractical? Like
They might be, but how do we test if they're impractical or not? We need to build a model of it to see is it really impractical or is it not impractical. Yeah.
Because wouldn't you need, because if you could just like call one to come to your house, wouldn't there need to be like tracks everywhere, or would it like need no tracks at all?
Well, the good thing is not everybody calls for the bus at the same time, only some set of people, right?
Plus, there's not just going to be one bus.
No, there would be
There's
dozens, hundreds of
buses.
buses,
And
right?
also you could get the buses to like communicate with each other. So only one bus knows to like come for the person.
Exactly. So
And it might not come exactly to you. Like maybe
Buses
it
might-
tell you to like come like to this corner.
that's
And
exactly
it's, like,
exactly
three
what
people
it
walk
does.
to that corner and like create a new stop.
See, look, you got it figured out. That thought process that you just went through right there. It took my 20-year-old students like an entire semester to wrap their head around that idea. Right? So, yes, hold your questions. I'll show you a couple more things. But the thing that I think, like I was saying, like these serious professors, when I say I'm going to do these serious things and I'm going to do it with video games, they think, no way. Video games, those are for kids, those are toys, they're not serious things. But the reality is that all of this work, the same tools that we're using to do this very serious stuff with data, are the same tools that video game developers use to make video games. And it's all based at some point on code, that interaction. Okay, so let's go here. All right. Back in time. Okay. Now, let's talk about BitSpace. Right, so I teach college kids. They come to college at 18. Some of them are as old. I think my oldest student right now is 30-something. And that's what I've been teaching for the last 14 years. And I teach everything from computer programming to drawing and modeling, basically how to do stuff with media and technology. Now, a year ago, I started a company that takes all of those same ideas and all of those same lessons and all of the same technology, and instead of teaching older kids, it's about teaching kids your age. So BitSpace is for kids as young as 6 and as old as 18. And at BitSpace we do a ton of different things. All the kind of stuff that I've shown you already, we teach kids how to do. So we have a robot here that cuts things out of lasers, right? So it uses a laser to cut wood, to cut plastic. We have a few 3D printers, obviously, that are printing in plastic. We have a ton of tools. All this stuff is for kids. So kids that come to BitSpace, they do sort of one of two things. They work with physical materials and they make things like this, like skateboards. There's a skateboard made by, I think, a 10-year-old from scratch. Alright, so you can see here's some dudes from summer camp made some cool skateboards. Real skateboards that work, entirely custom. They made these over a week time. So we have these 3 programs, Bits, Prints, and Bytes. And Bytes is where the coding happens. So I still code, I still teach code. Paul teaches coding at BitSpace. And you can see that these are the kinds of things we do. So we teach kids how to make video games, how to make interactive worlds that are not limited to the blocks of Minecraft. Right? Minecraft's awesome, but you can't ever make anything that's not made out of blocks, right? In our tools, you can make whatever you want with whatever you want, right? It's a little bit more tricky, it's a little bit more complex, but the tools that we teach the kids are the same tools that professionals are using to make games that I guarantee are on all of the phones that your parents own. Right, so this is real software. The other thing that we teach programming for is how to make robotic stuff, right? So how to connect sensors to small computers, how to use that small computer in programming to control things like lights, motors, screens. This is about making interactive physical things, right? And here's an example, and we'll get to see how this works in a second. One of the things that we've made recently for our camps is we have this cool game that you play in the Oculus Rift. So you put the Oculus Rift on, you go inside, and there are 5 silver balls inside of this model of BitSpace. And you pick them up, and you can pick them all up and gather them in 2 minutes time, then you win the game. What? Time? The next part of this, though, the kind of tricky part, the fun part, the cool part, is that downstairs at BitSpace, there's this big wooden model. It doesn't really look like BitSpace, but it's supposed to be a model of BitSpace. And you see all these buttons? They're like arcade game buttons. They're in that model. The cool thing is that there's 2 games. So there's a game that you play inside the Oculus Rift, but then as an extension of that game, you go downstairs and you mash all these buttons. And when the kids hit all the buttons, what it does is it fires out inside of this virtual reality model, it fires out a whole bunch of white balls. and then it's hard to find the silver ball. So it's a game where the kids are like downstairs, they're pounding and they're trying to be the obstacles, fill up the space with white balls. Meanwhile, the person in virtual reality is running around trying to pick them up. Okay? So all of this stuff, I haven't really shown you a lot of code. I don't think looking at code is terribly exciting. But all of the things that I've shown you today, in some way, shape, or form, involve the use of code to make it interactive, or maybe to decide the shape of it, or decide where it should be, to help us make decisions, to help us design, to help us to make things. Okay? Do you have a question?
That small computer that you were talking about,
Mm-hmm.
was that a Pi, an Arduino, or something
It's an
else?
Arduino. Yeah, it's an Arduino. Yeah.
Did you design that the like area that space is?
I designed it and I built it myself. That's the thing. Like and this is where for me, computer programming. The reason why I think computer programming is so cool is because I can make stuff. You know, it's like I don't know how to fix my car. Like if I pop open the hood of my car, I can't fix my car. It's a black box that I don't know how to figure out. But I can open up a piece of software and I can figure it out and I can make that. And I can get a saw out and I can cut some wood and some plastic and I can put it together and I can make things. Like that's what I'm really interested in. That for me is what programming enables. Is for me, instead of just using games or instead of just using an app or instead of just using a website, I can actually make those things from scratch. And other than having a computer, which isn't so expensive anymore, it doesn't really cost anything, right? It's all just up here in your head. So it's really exciting in that way.